Hello, dear students. I am glad to meet you at our course. Today we are going to talk about tall buildings, past and present trends. Let's start. The passion, obsession, and necessity of building super tall and mega tall structures continue to challenge engineers and architects to reach new heights and go where no man has gone before. Vertical habitation isn't a new trend. It's one that has been driven by urbanization and bustling, overpopulated cities for centuries. While the high-rise buildings that we know today became possible with the inventions of elevators, newer building materials, and structural engineering systems, multi-story construction dates back to the Roman Empire, and vertical cities have been around for centuries. A living example is the 16th-century Yemeni city of Shibam, with mud brick tower houses of 5 to 8 stories high, built to protect the occupants from Bedouin attacks. Tall buildings are central to the development of future-ready cities. Adding value to the mega-developments of which they are a part, tall buildings have become essential as a means of overcoming the challenges of increasing urbanization and density, combined with the need to enhance livability and sustainability in our urban habitats, particularly in the emerging economies of the world. The competition for constructing the tallest building in a city, country, region, or the world has acted as another driver for the growth of tall buildings worldwide. In the past 2 decades or so, the race for constructing the tallest has been extended to include the contest for constructing the most iconic and spectacular high-rise buildings, often characterized by complex geometries and leaning, twisting forms. Over the years, the Council of Tall Buildings and Urban Habitat (CTBUH) has been recording data on tall building structures, showcasing how they continue to rise in height. Today, according to the definition of tall given by CTBUH, a 200 meters plus building is tall, 300 meters plus is super tall, and 600 meters plus is mega tall. However, architectural and structural factors such as the context of the building, its location, and the slenderness of the building, i.e. its height over base ratio, demand more flexible definitions. Skinny skyscrapers, for instance, aren't possible everywhere, and this has more to do with the target market and location than engineering and design capabilities. An example of this is the super skinny tall buildings in New York City, where each apartment is a penthouse that occupies an entire floor of the building. Engineers consider tall buildings with a height-to-base ratio in excess of 1 to 10 or 1 to 12 to be slender or skinny. The design and the form of original super tall buildings used to be structurally driven, such as the John Hancock Center of 1969 had exposed structural steel as a part of the design. Today, architects and designers have more form freedom than ever before. Advancement in design and construction techniques allows engineers to assist their architect colleagues to create buildings that would have been unimaginable a few decades ago. While complex forms would often increase construction costs, a careful and sophisticated engineering approach is required to achieve the architectural vision without unnecessary cost overruns. Whether it is in the choice of the lateral load-resistant structure and/or floor systems, or in the approach for integrating the structure in the overall geometry and architecture of the building, the decisions made by the structural engineer have a profound impact on the cost, amenity, constructability, and sustainability of tall buildings. The locations of the tallest buildings in the world, as well as the function of the buildings and the materials used to construct these buildings, are rapidly changing. Only 20 years ago, 75% of the 100 tallest buildings in the world were located in North America, and as of 2014, this figure is less than 25%, with the shift occurring predominantly in Asia and the Middle East. The function of tall buildings has also changed in a significant way over the past years. In the past, the function of the 100 tallest buildings in the world moved away from the predominantly office buildings that have dominated the tallest lists for many decades to more residential and mixed-use functions. Growing populations and rapid urbanization in developing countries explain why so many tall buildings are being developed for residential and mixed-use purposes instead of for commercial office use. The structural materials used in high-rise buildings are typically one or a combination of reinforced or pre-stressed concrete, structural steel, and composite systems. Structural material systems for high-rise buildings should be chosen by carefully considering architectural, economic, and site factors. The economic drivers vary by geography, as the relative costs of material, labor, time, and space vary from one location to another. Other factors to consider in choosing the structural material include local market preference availability, project size height, building form regular versus complex, design considerations fire performance, dynamic performance, adaptability, and the like, site location, access, and speed of construction. Preferences and the economic viability of the different structural materials that are used in tall buildings construction are also changing. In 1970, 90% of the 100 world's tallest buildings were all steel buildings. Today, all steel buildings account for less than 15% in favor of concrete or composite structures. The cost of the material, technological expertise, and the way that tall buildings are being built all influence this change in the material selection of tall buildings. From a structural engineering point of view, as high-rise buildings get taller and more slender, their design becomes increasingly and fundamentally influenced by specific behavioral factors that are much less significant for shorter buildings. These factors include the dynamic response of tall buildings to wind loads both in the ultimate and serviceability limit states and the differential axial shortenings of the vertical elements of tall buildings under gravity load effects. As far as these factors are concerned, the absolute height of the building is not necessarily the best measure for tall behavior. In particular, the magnitude of the dynamic wind response is more significantly influenced by the overall slenderness of the building and the natural frequencies of its fundamental modes. It is the first two sway modes about the principal axis of the building, and its first torsional mode, then its absolute height. Thank you for your attention, dear students. Next time we are going to study technological trends in high-rise buildings. See you next time. Goodbye.